An electrical messenger is an object or mechanism used to transmit information, data, or signals between two or more points. Firstly, conductive wires carry electrical signals or power. They are used in electrical circuits, power distribution systems, and data transmission networks. Secondly, optical fibers are thin, flexible strands of glass or plastic that transmit light signals, used for high-speed data communication and long-distance transmission. Thirdly, radio waves are electromagnetic waves that can travel through the air and other mediums, used for wireless communications such as cell phones, Wi-Fi, and Bluetooth. Fourthly, Bluetooth is a short-range wireless technology that uses radio waves to connect devices, used for connecting peripherals, for example, headphones and keyboards, to computers and smartphones. Fifthly, infrared signals are invisible light waves that can be transmitted through the air or through objects, used in remote controls, motion sensors, and optical communication systems. Sixthly, serial and USB cables are data cables that connect devices and allow for the exchange of information, used in computer peripherals, industrial systems, and data transfer applications. Seventhly, network switches and routers are devices that facilitate the transmission of data packets in computer networks. They route and manage traffic, ensuring that data reaches its destination. Messengers transmit information over distances, establish and maintain communication channels, allow for the exchange of data and signals, and provide a reliable and efficient means of communication. In more detail, let's explore wires. Wires are the fundamental building blocks of electrical systems. They serve as the primary medium for conducting electrical current from one point to another. Different types of wires are available, each designed for specific applications and current carrying capacities. The material of the wire, typically copper or aluminum, determines its conductivity. Copper is preferred due to its higher conductivity and lower resistance, which minimizes energy loss during transmission. The size or gauge of the wire determines the amount of current it can safely carry. Larger gauge wires have lower resistance and can handle higher currents without overheating. National Electrical Code Table 310.15 provides guidelines on the ampacity or current carrying capacity of different wire sizes based on their insulation type and installation conditions. Insulation is another critical factor for wires. It prevents electrical current from leaking out of the wire and causing short circuits or electric shocks. Common insulation materials include polyvinyl chloride, polyethylene, and rubber. The type of insulation used depends on the voltage, temperature, and environmental conditions of the application. For example, high-temperature insulation is required for wires used in hot environments like industrial ovens. Wires are used in a wide range of applications, including power distribution, lighting, appliances, and electronic devices. In power distribution systems, wires carry electricity from the power plant to homes and businesses. In lighting circuits, wires connect the light switch to the light fixture. In appliances, wires supply power to the motor and other components. Optical fibers are a modern alternative to wires for transmitting data over long distances. Unlike wires, which transmit electrical signals, optical fibers transmit light signals. This offers several advantages, including higher bandwidth, lower signal loss, and immunity to electromagnetic interference. Optical fibers are made of thin strands of glass or plastic. Light signals are transmitted through the fiber by total internal reflection. This means that the light bounces off the walls of the fiber and remains confined within the core. The core is surrounded by a cladding, which has a lower refractive index than the core. This ensures that the light is reflected back into the core. Optical fibers are used in telecommunications, data networks, and medical imaging. In telecommunications, optical fibers transmit telephone calls, internet data, and video signals. In data networks, optical fibers connect computers and servers in local area networks and wide area networks. In medical imaging, optical fibers are used to transmit light to and from internal organs for diagnostic purposes. Radio waves are another type of messenger used for wireless communication. Radio waves are electromagnetic waves that can travel through the air and other mediums. They are used to transmit information over long distances without the need for physical wires. Radio waves are characterized by their frequency and wavelength. The frequency is the number of waves that pass a given point per second, measured in hertz. The wavelength is the distance between two consecutive peaks or troughs of the wave, measured in meters. Different frequencies are used for different applications. For example, AM radio uses frequencies between 530 kHz and 1710 kHz, while FM radio uses frequencies between 88 MHz and 108 MHz. Radio waves are used in a wide range of applications, including broadcasting, mobile communication, and radar. In broadcasting, radio waves transmit audio and video signals to radio and television receivers. In mobile communication, radio waves connect cell phones to cell towers. In radar, radio waves are used to detect and track objects such as airplanes and ships. Bluetooth is a short-range wireless technology that uses radio waves to connect devices. It is commonly used to connect peripherals such as headphones, keyboards, and mice to computers and smartphones. Bluetooth operates in the 2.4 GHz frequency band. It uses a technology called frequency hopping spread spectrum to minimize interference from other devices. This means that the Bluetooth device rapidly switches between different frequencies to avoid interference. Bluetooth devices can communicate with each other within a range of about 10 meters. Bluetooth is used in a wide range of applications, including audio streaming, data transfer, and device control. In audio streaming, Bluetooth transmits audio signals from a smartphone to a wireless speaker. In data transfer, Bluetooth transfers files between two computers. In device control, Bluetooth controls a remote control car from a smartphone. Infrared signals are invisible light waves that can be transmitted through the air or through objects. They are commonly used in remote controls, motion sensors, and optical communication systems. Infrared signals have a wavelength between 700 nanometers and 1 millimeter. They are located on the electromagnetic spectrum between visible light and microwaves. Infrared signals are transmitted by light-emitting diodes, LEDs. The LED emits infrared light when an electric current passes through it. The infrared light is then detected by a photodiode or phototransistor. The photodiode or phototransistor converts the infrared light into an electric current. Infrared signals are used in a wide range of applications, including remote controls, motion sensors, and optical communication systems. In remote controls, infrared signals transmit commands from the remote control to the television or other device. In motion sensors, infrared signals detect the presence of a person or object. In optical communication systems, infrared signals transmit data between two devices. Serial and USB cables are data cables that connect devices and allow for the exchange of information. Serial cables transmit data one bit at a time, while USB cables transmit data multiple bits at a time. Serial cables are commonly used to connect older peripherals, such as mice and keyboards, to computers. USB cables are commonly used to connect newer peripherals, such as printers, scanners, and external hard drives to computers. USB cables are also used to charge mobile devices, such as smartphones and tablets. Serial cables use a variety of connectors, including DB9 and DB25 connectors. USB cables use a variety of connectors, including USB Type-A, USB Type-B, USB Type-C, and mini USB connectors. Serial and USB cables are used in a wide range of applications, including computer peripherals, industrial systems, and data transfer applications. In computer peripherals, serial and USB cables connect peripherals to computers. In industrial systems, serial and USB cables connect sensors, actuators, and controllers to industrial computers. In data transfer applications, serial and USB cables transfer files between two computers or between a computer and an external storage device. Network switches and routers are devices that facilitate the transmission of data packets in computer networks. Switches connect devices within a local area network, LAN, while routers connect different networks together, such as LAN to the Internet. Switches forward data packets based on the Destination Media Access Control (MAC) address of the device. Routers forward data packets based on the Destination Internet Protocol (IP) address of the device. Switches and routers are used in a wide range of applications, including home networks, business networks, and data centers. In home networks, switches and routers connect computers, smartphones, and other devices to the Internet. In business networks, switches and routers connect computers, servers, and printers to the Internet and to each other. In data centers, switches and routers connect servers and storage devices to each other and to the Internet. A messenger in an electrical system is a broad term that encompasses various methods and components used to transmit information, power, or signals between different points. The choice of messenger depends on the specific application, distance, data rate, and environmental conditions. Understanding the different types of messengers and their functions is essential for designing and maintaining efficient and reliable electrical and communication systems. To summarize, firstly, wires are used for conducting electrical power or signals, mainly for shorter distances, and require physical connections. Secondly, optical fibers transmit data using light signals, ideal for high-speed, long-distance communication. Thirdly, radio waves enable wireless communication over varying distances, suitable for mobile and broadcast applications. Fourthly, Bluetooth provides short-range wireless connectivity for devices like headphones and peripherals. Fifthly, infrared is used for short-range, line-of-sight communication, commonly in remote controls. Sixthly, serial and USB cables facilitate wired data transfer between devices. Seventhly, network switches and routers manage data traffic in computer networks. Each type of messenger plays a crucial role in its respective application, ensuring the reliable and efficient transfer of information and power.